Hello, and welcome back to LearnSBOM. I'm Liam, and today we will be looking at the Vexy tool created by Paul Horton. Vexy is able to generate Vex documents in CycloneDX format through a supplied CycloneDX SBOM. The main goal of this tool is to be able to generate a Vex to keep vulnerability information up to date without having to generate a new SBOM entirely. Installation is simple, as it is through the Python package index. You can install the tool using your preferred Python package manager. For this demo, I've installed the tool using pip. Once installed, we can bring up Vexy's help message to show us how the tool works and what flags we can use. We can get the help message through the following input. Now we can see all possible flags and which ones are required in order to use Vexy. Two inputs are required to generate the Vex document. The first is the input file. You will need to specify the file path to the CycloneDX SBOM that is read to create the Vex document. This can be done with the infile flag. You can also use a dash to read from standard input instead of a file. The second required input is for a Vexy configuration file. This file specifies what data sources the tool will use to find vulnerability information. Currently, only two data sources are available for use with the tool, OSSIndex and osv.dev. You will need to create a YAML file to input the sources to use. Here we can see the YAML file I have already created, with both tools specified as sources. OSSIndex also allows for you to input your username and password if you have a Sonatype account. You would just need to add this info underneath the OSSIndex line. An example of this can be seen in the Vexy documentation. With these two flags, we can now generate a Vex document. C for config, and I for input file. If the tool is successful, an XML document will be created in the current directory. Here we can see the generated Vex document from Vexy. It outputs on one line only though, making it difficult to read and understand without manually fixing it. There are several other flags to use with this tool. First, we can designate the output format of our Vex document using the format flag. By default, the document will output in XML format, but the tool also supports JSON output. You can also designate the CycloneDX schema version for the Vex document, but this flag can only allow for schema version 1.4, which is also the tool's default schema, so this flag is currently not of much use. Hopefully 1.5 compatibility will also be available for Vexy in the near future. Another flag that can be used is designating the output file path for the document. This can be done using the output flag. You can either input a file path for the Vex document, or you can use a dash to output to standard output in the console. I will be using a dash. By default, if the output path already exists, a file exists error will occur, and the Vex document will not save. The tool can overwrite this file using the force flag. Finally, you can alter the console output while the tool is running. You can use the quiet flag so no output occurs, or you can use the debug flag to enable debug output. Overall, Vexy does a solid job generating Vex documents through CycloneDX SBOMs. However, saving the documents all on one line is tedious and hard to read. Having no support for SBDX SBOMs as well makes the tool a little limited in its input formats. The tool can also only output Vex documents in CycloneDX format, rather than also supporting CSAF format. Hopefully these problems and enhancements can be fixed in the near future and implemented in the tool, as there aren't many open source software Vex tools at this time. Thank you so much for watching. If you have any questions, comments, or concerns, feel free to reach out to us at LearnSBOM.com.
Thank you for checking out this video. If you really liked it, be sure to check out our other videos right here, and then you can also subscribe right up top here. And again, thank you. Bye-bye.